This video is about trigonometry. If you have something like sin23 or cos10 or tan45, there are 5 ways to work out its value. This video is about those 5 ways. The most familiar way to you will be just to use the calculator, just literally to type it. So you go sin23 and then press equal sign. As long as there is a D or a DEG up the top of the screen, then that method will work just fine. The second way is also familiar to students above Year 9. If you can see the angle that you want to do trigonometry on inside a triangle, such as this one, then of course you can use SOHCAHTOA. So tan 45 equals the opposite divided by the adjacent, and so therefore it must be 1. So number 2 is when you have a triangle all set up, you can physically see the triangle and you have the sides that you need. So using a bit of Pythagoras there, I can now work out what sin 45 is. It's 1 over root 2. The third way is just to know them. So when I talk about 5 ways to find sin23, I'm not talking about 5 clever methods. I'm talking about 5 physical, actual, real ways to fish up sin23 in an exam context. And number 3 comes from the fact that some teachers encourage students to know at least 9 of these off by heart. And those 9 are sine, cos and tan of 30, 60 and 45. So I'm an example of a teacher like that. I say to students that they must learn that sine 30 is a half. They must learn that cos 60 is the same thing. Sine 60 is root 3 over 2. Cos 60 is the same thing. Tan 30 is 1 over root 3. Tan 60 is root 3. Tan 45 is 1. Cos 45 is 1 over root 2. And sine 45 is 1 over root 2. So that's your third way, just to know them off by heart. So when I say, what's sine 30? You say half, just like that, instantly. Now, your fourth way is a thing called swinging around the circle. Now, this should only be used some of the time. It should only be used for angles that are multiples of 90, including negative ones. Now, the way you think about angles that are multiples of 90, or negative multiples of 90, like negative 180, is to set up a circle of radius 1, called the unit circle, and what you do, I'm just going to make sure this is good for my demonstration in a second. And what you do is you adopt the following thinking device. You always start imagining that you had a little paperclip there. And when I say the angle, so if I say 90, you swing that many degrees anti-clockwise. So you start there and you swing that much, and you imagine putting a great big fat dot exactly where you land. So that's why I'm putting a fat dot there. If I said negative 180, swing the other way. So start there, negative 90, negative 180. So my fat dot from negative 180 is there. Another example would be positive 270. So it's 90, 180, 270. that lands you there. Another example could be 450. That's 90, 80, and 60. So 450 there as well. Now, here's the thing. If I actually ask you trigonometry about one of these, then the sine is the y-coordinate of the fat dot where you landed. So sine of 90, if you swing 90, you end up there. The y-coordinate of that is 1. So the cos of negative 180, start there, negative 90, negative 180. The y-coordinate of that is 0. So sine is the y-coordinate of the fat dot where you end up after you've done your swinging around the circle. I don't know why I wrote cos there, that should be sine. Now, another example would be this. If you really did have to swing 360,090 degrees, I think that would be 1,000 times round the unit circle, which would land you back there again, plus an extra 90. So therefore your y-coordinate will be 1, therefore sine of that angle is 1. So that's what you do with sine. If you get asked cos, then you do exactly the same thing. You take your angle, you swing that much anti-clockwise, or clockwise if it's negative, but this time you ask yourself what the x-coordinate is. So the x-coordinate of that fat dot, that landing position, is 0. If you swing negative 180, you end up there. The x-coordinate of that fat dot is negative 1. And let's say cos of 540. That's 90, 180, 270. $450, $540. So the x-coordinate of that is negative 1. Now, that's sine and cos. Tan is the hassle-some one. If you get asked a tan question, you need to do two things. But what you do initially is exactly the same thing. So if I say what's tan of 720, you go 90, 180, 270, 360, 450, 540, 630, 720. So there's your fat dot. What you have to do for sine is, first you ask what its y-coordinate is, and then you ask what its x-coordinate is, and then you divide one by the other. So basically you form a fraction where the top is sine and the bottom is cos. So that's what tan is. Okay, it's a hassle-some one because you actually have to do two questions in one. A sine question for the numerator and a cos question for the denominator. This means, by the way, that you can sometimes get math error. So negative 270, negative 90, negative 180, negative 270. What's the y-coordinate of that? 1. The x-coordinate of that? 0. So you can't divide by 0, so that's undefined. Now, it should be obvious the reason why I said only use technique 4 if your angles are multiples of 90. It's because only multiples of 90 make it crystal clear what the y-coordinate and x-coordinate of your landing points are. Basically, it's only the angles that are multiples of 90 which land you there, 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 or there. So do not always use technique number 4. Do not always swing around the circle. Okay? Now, technique number 5 is as follows. It's a principle. Trigonometry of big angles can be handled using small angles. Now, what I'm going to do is explain to you what I mean by that. And it's this. I'm going to give you a whole bunch of examples. You're not supposed to know how I'm getting these yet. They're just supposed to be illustrations of how trigonometry about big angles becomes trigonometry about small angles. So if I was dealing with sine of 361, I would instead do sine of 1. If I was dealing with cos of 359, I would instead do cos of 1. If I was doing sine of 150, I would instead do sine of 30. And if I was doing tan of 200, I would instead do tan of 20. So this is 4 examples of the principle. Big angles suddenly become questions about small angles. This is a very good principle. It means, for example, that sine 150 you can do straight away if you know the table that I talked about 10 minutes ago. Because sine of 30 is half, so therefore if you know that, you can look at sine 150, see the big angle, turn it into a question about the small angle, and then get the answer. These ones, it's not got you completely there. You now need to use a calculator for those. But the point is you don't have to worry about the fact that the angle is big. Now, from these 4 examples, some of you watching the video might have been able to work out how I was getting these. Okay, if that's the case, I'm now going to make it a bit complicated for you. Sine 91 is the same as sine 89. Cos of 182, here's another complication, is not cos of 2, it's negative cos of 2. Tan of 370 is the same as tan of 10. And cos of 330 is the same as cos of 30. And sine of 359 is negative sine 1. Well, how am I doing those? The way that I'm picking these angles is just by imagining swinging around the circle and asking myself how far short of or beyond the x-axis do I fall. So if you swung 361, so I'll do my diagram again, I think you would go 90, 180, 270, 360, you would go an absolute slither past the x-axis, past your returning home, and so that's why the number 1 has turned up there. Same with 359, it's just this time you fall 1 degree short of. So these angles here, the small angles, which technically are called auxiliary angles because they help, it's from the Latin word auxilium meaning help, they are always how far short of or beyond the x-axis did you fall. That's why this one doesn't actually give you that much help. Because if you go 91 degrees, you go 90, you go an extra 1 degree, how far you pressed on past the y-axis is irrelevant. What matters is how far you fell short of the x-axis, and that is a very substantial 89 degrees. Now, why do some of them have negatives on them? Well, it's to do with the fact that sine is the y-coordinate and x is and cos is the x-coordinate, and tan is sine divided by cos. So that's why some of them have negatives, because some of the time your fat dot is above the x-axis, some of the time it's below the x-axis. Some of the time it's to the right of the y-axis, some of the time it's to the left of the y-axis. But students do not tend to think through these issues from first principles. What they instead do is use the following device. This is a famous device that all students come to know. Basically, if I ask you a trigonometry question, you're in the swinging in the circle and you land there, then every possible question I ask you will have a positive answer. And that therefore has the abbreviation A. A stands for all. All 3 of sine, cos and tan will give a positive answer if the fat dot you end up with when you